Hi, I'm Hw5. This is my video for the homework 5. And for the problem, we know that x, y are independent, and z is equal to x plus y. We using the convolution method and the geometry method to find the density function of z. So first, according to the convolution definition, when according to the convolution definition, we know that the density function of z is equal to the integral of fx alpha multiplied by fy z minus alpha. So for the density function of x, this is equal to the u alpha minus 1. And for this part, this is equal to uz minus alpha minus 1 minus uz minus alpha minus 2. So we are using the step function to represent the density function of x as y. So for this integral, according to the different parts, we separate this into the 4 parts. So the first part is the first part actually is from 0 to z minus 1 according to the step function property, and here multiplied by the uz. And similarly, we do the same thing for the remaining 3 parts, and we can easily get the results z minus 1 multiplied by the step function of z minus 1 minus 2 multiplied by z minus 2 multiplied by step function of z minus 2 plus z minus 3 multiplied by the uz minus 3. And so for the geometry method, first we assume the density function of y is uy minus uy, which means that the y is from 0 to 1, not from 1 to 2. So this can be easily represented in the picture. So when we get the result for this function of y, we can easily remove the plot from left to right with one union to get the correct result. So first we are using this one. So for z smaller than or equal to 1, so this square is included by the big, this triangle included by the big square, and so we can easily, according to the area get the distribution function of fz equal to 1 over 2 multiplied by z squared. So density function equal to z. So for z is greater than minus y smaller than 2, so this triangle is not included in the square. So this shadowed area equal to this big triangle minus the smaller triangle, which is equal to this. So this function equal to the minus z plus 2. And also for z greater than 2 and z smaller than 0, there is no intersection with the triangle and the square, so this function is equal to 0. So we can easily draw the picture like this. And so what if the density function is equal to uy minus 1 minus u minus 2, which means from 1 to 2, not from 0 to 1. We just easily move the triangle to the right with one union to get this good result. So according to this, we can know this equal to zuz minus z 2 z plus 1 u minus plus 1. So actually, this should be equal to z minus 1 u z minus 1 u z minus 1. So minus 2 plus z minus 2 plus this will be, oh yeah, no, sorry. So actually this part stands for this fc. So for this plot, fc is equal to z minus 1 u z minus 1 plus this, which is the same result as we get from the first method. Okay, so this is homework 1. So for the homework 2, we get this density function, and we need to draw the non-zero definition region of fy. So it can be divided. So we separate. So according to this area, we know that xy greater than y, which means y greater than x plus 1. This is because x is greater than 1 over y and y is greater equal to 1. So x is greater than 0. So this should be y greater than 1 over x. And we all know that y is greater than x, so we can draw this. This is the region of fxy. So according to the property, the distribution of infinity and infinity should be equal to 1. So we insert this property into the we insert the density function into this distribution function, and let the y is and let xy equal from the minus infinity to infinity, which is equal to y. So we let a equal to log y, which is, we can change the integral from this format. So according to the calculation, we can easily get a equal to 1 over 2. And for the third part question, we need to draw the marginal density function of fxy. So according to property, fy equal to minus infinity to plus infinity fxy dx, which equal to log y over y squared. And so, we can also do a check to see if there are validated functions while using the property. So y is greater than 0. So from 0 to infinity, the integration of fy is equal to y. So fy is a validated function. So, and for this part, we're using the formula that the integral of xn multiplied by log x is equal to this. So actually this is a hard integration, so we need to use a formula. So this is the plot for the density function of y. And similarly for the x, so for the x, according to the definition, we're using the formula to calculate the fx according to the fxy, which is equal to 1 over 2. So for the x greater than 1, smaller than 0, so this is 1 over 2 multiplied by x squared. So this is the plot, and we check if it is a valid density function. So from 0 to infinity, the integration of fx equal to 1. So this is also a valid density function. So that's it. This is my video for the homework 5, problem 1, and problem 2.